Finding Composite Functions with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. A composite function is a combination of two or more functions, where the output of one function becomes the input of another. It can be written as f(g) of x, which means that we apply g first and then apply f to the result. So after applying the function of g, we would then need to substitute the output from this into the function of f, hence giving us f(g) of x, with the function of f of x equals 2x plus 1. And you can see inside the bracket where we have x, this is going to be replaced or substituted with the function g of x. So starting with 2x plus 1, replacing x for the function g of x, we'll substitute 1 over x in place of x, giving us 2 lots of 1 over x plus 1, and simplifying this will give me 2 over x plus 1. For the next question, I'm starting off with f of x and substituting this into the function of g. So where we had 1 over x, we will replace x with the function of f, which is 2x plus 1. And this won't simplify any further, meaning that my final answer would just be 1 over 2x plus 1. For the third question, we're substituting the function of f into the function of f. So I have 2x plus 1, and I'm replacing x for 2x plus 1, giving me 2 lots of 2x plus 1 plus 1. I will be able to expand and simplify by collecting like terms, so I must do that. Expanding the single bracket, 4x plus 2, adding 1, gives me a final simplified answer of 4x plus 3. Lastly, when evaluating a composite function, where we're substituting a numerical value rather than an algebraic expression, you can find the composite function of x, which we've already done here, 4x plus 3, and substitute negative 2 in place of x. So 4 lots of negative 2 plus 3 gives us negative 5. The quickest and easiest way to do it, assuming they've not already asked us to find what f of x is earlier on in the question, would just be to substitute negative 2 as your input into the function of f. 2 lots of negative 2 plus 1 is negative 3, and then substituting the output from this as the input into the other function, which again I'm using the function of f. So in place of 2 lots of x, it would be 2 lots of negative 3 plus 1, which gives me negative 5, as previously worked out. On to the intermediate question with an increase in difficulty. If f of x equals x cubed minus 2x and g of x is equal to x plus 1, find f(g) of x, simplifying our expression. I'll need to take the function of g of x and substitute this into the function of f. So each time I see x in my function of f, I'm going to replace this for x plus 1. So x plus 1 cubed minus 2 lots of x plus 1. I will be able to simplify by expanding and collecting like terms. X plus 1 cubed will give me triple brackets. If I just focus on expanding 2 of those brackets first, x plus 1 multiplied by x plus 1, I'll get x squared plus 1x plus 1x plus 1. And simplifying by collecting like terms will give me x squared plus 2x plus 1. I can then multiply this by the third bracket of x plus 1, giving me x cubed, and 1x squared plus 2x squared is 3x squared. 1x plus 2x is 3x, and then plus 1 at the end. And expanding the last bracket, negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. I can simplify by collecting like terms. X cubed will remain the same, plus 3x squared will also remain the same, but I will be able to collect 3x, take away 2x, to give me plus x or plus 1x, and then 1 take away 2 gives me negative 1, meaning my final answer for a simplified f(g) of x is x cubed plus 3x squared plus x minus 1. On to the advanced question, one of the trickier questions that you're likely to find on this topic. For all values of x, f of x equals x squared plus 5, and g of x equals x minus 4. We need to solve when f(g) of x is equal to g f of x. Let's first start by finding each of these composite functions. I'll start with f(g) of x. The function g of x is being substituted into the function of f. So within my function of f, I'll be replacing every time I see x with x minus 4, giving me x minus 4 squared in a bracket plus 5. Expanding the double bracket, x minus 4 squared will give me x squared minus 8x plus 16 plus 5. I will be able to simplify by collecting like terms, leaving me with x squared minus 8x plus 21. I can do the same for g f of x. So the function of f of x is being substituted into the function of g. So starting with x minus 4, and every single time I see x, I'm going to replace it with the function of f, which is x squared plus 5, giving me x squared plus 5 in a bracket, and then take away 4. And simplifying by collecting like terms will just leave me with x squared plus 1. Now since I'm solving when these two composite functions are equal to each other, I can make x squared minus 8x plus 21 equal to x squared plus 1. This could be solved by rearranging to make equal to 0, which will involve subtracting x squared and 1 from both sides, leaving me with negative 8x plus 20 is equal to 0. I thought I might end up with a quadratic equation that needed to be solved here by making it equal to 0. But actually I can isolate the term that involves x, so negative 8x on the left hand side, and then take away 20 from both sides, multiplying through by negative 1, 8x is equal to 20, and then dividing through by 8 to leave me with my solution for x, which is 5 over 2, or 2.5. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.